Welcome to Luca is a Billionaire, where the only thing I invest in is your answers.
You start by preparing your environment. Install Python 3. 8 or newer, create a virtualenv, then pip install Vosk sound device numpy. Once done, download a Vosk model that matches your language and CPU capability. Smaller models speed testing. You need to identify your microphone index using sound device. Query devices, because passing the wrong device will silently fail. Make sure permissions are granted for audio capture. This gets you from 0 to the first runnable script quickly and reliably. Now integrate Vosk into your Python code. Import Vosk and load model path, one time to avoid heavy reinitialization. Next, open a sound device. Input stream configured to the model's sample rate, typically 16,000 HZ, mismatched rates cause garbled transcripts. Inside the stream callback, convert to 16-bit PCM and call Caldi Recognizer. Accept waveform frame. Use recognizer. Result for interim text and recognizer. Final result when speech ends. Finish by gracefully closing the input stream and deleting or letting the model go out of scope to free memory. Save partial and final transcripts to disk and support a hotkey or signal for clean shutdowns. If something goes wrong, first replay a known good WAV through your code at the model's sample rate to separate capture from recognition problems. If accuracy is poor, switch to a larger model, improve microphone quality, or increase sample rate. These choices trade latency and memory for better recognition.
Thanks for watching and please subscribe. It's the best investment you'll ever make.